which line has a greater slope? Meaning, if you were going to start in this bottom left-hand corner and walk up those lines, which line would be more challenging for you to climb up? That's what the question is asking. The nice thing here is either you click on red or blue and you make the choice, right? Make that decision, click on red or blue. I'm going to anonymize it. I want to see what you guys are thinking. Which hill would be harder to climb? Yes, nicely done. It is the blue one. Again, as you start in that bottom left-hand corner and you climb up that hill, that would be more challenging, right? Because it's steeper. We talked about last week that the steepness of a graph is the same thing as its slope, okay? So blue, nicely done. All right, take a look at slide 3. We talked also very briefly about positive and negative slope. Again, as you're starting on the left-hand side of each line, which one do you think would have a negative slope? Do you think it's the red one, or do you think it's the blue one? Noah, buddy, can you come up to slide 3, please? Thank you. Isa, click the button on your screen, man. All right, let's see what you see here with this one. Which one is negative? Think of it as which one would be more like sliding down a hill or going down a slide if I go from left to right. Left to right, left to right. You should be switching to blue. Right, Rainier? Negative slope. Yes. All right, negative slope goes from the left down to the right. Okay, think about it as if you're going down a slide or you're going to go sledding. You're at the top of that hill and it goes down to the right. That's when we have a negative slope. Hey, fix your answers there. Get those answers switched to blue there on slide 3 so that you have notes and resources to look back at, okay? All right, next question. Look at slide 4. All right, slide 4. In a previous lesson, we talked about lines that don't have slopes. They have slopes that are neither positive or negative. There are special circumstances. Draw me an example of one of those 2 lines or circumstances that we talked about that were special cases where they are not positive nor are they negative. Pick a color and draw me a line to show not positive nor negative. Let's see what you got. I see 3 people on my slides. I think there's a line here. That might be a 4th one. Hey, question for you. If you look back at slide 3 and you know that slide 3 shows a red line having a positive slope and the blue line having a negative slope, And I'm pretty sure you can't have a slanty line to show something that doesn't have positive or negative slope. Some of you have fixed it. Nicely done. Switch over to my screen if you don't mind, please. Look at the meets. All right, so in the meets, we talked about actually one of the lines that we had in the slides last week was that person standing right at the edge of the cliff, wondering should they go skiing down that cliff or not. Remember, that line was a vertical line, and that is what we call undefined. My writing is terrible. Undefined. Oh my goodness, I better just erase that. That's awful. The lag here on the screen is horrendous. Let me see if this pen will work better. Undefined. All right, so this vertical one is undefined. And then there was one other special one, which I saw some of you graph. And I'm going to switch to my, I'll go purple. The other one is this one. It was the picture of like the driveway kind of, and we talked about going cross-country skiing. And this one would be really boring. This flat line, my purple one, has a slope of 0. Okay, those are the two special circumstances that we've talked about. I'm going to leave my slide 4 up. I want you to go back and forth between your slide 4 and mine, and I would like you to update your graph and then move on to slide 5 when that is done. So go back and forth between my slide 4 and your slide 4 to make sure that you've got those two lines graphed. Similar to mine, they don't have to be in the exact same spot. But I would like them similar. You need one that's vertical and you need one that is side to side. Good, Davon, those are good. Good, Martez. Some of you put them right on the X and Y axes. That's just fine. Sensei, buddy, let's get logged into this Desmos, please. The lesson 4 folder. Let's go, buddy. Folks, you should be copying your stuff or copying my slide onto your slide 4 so that you have an example. When you are done, pop up to slide 5. I'm going to move up to slide 5 in 10 seconds. Get those lines done. Five, 4, 3, 2, 1. Good, Aiden. I see yours in there. That's good. All right, so here's the thing. Here's another slide for you to use as a reference point. There isn't anything for you to do on this slide other than to use it as a point of reference. If you have a cell phone or even with your Chromebook, it might be a good idea to take a picture of Mr. Slope Guy so you can have this as a reference, because everything you need to know about slope in terms of positive, negative, undefined, and 0 are actually in this picture. First things first, if you see the eye, that looks like a plus sign, and the eyebrow goes from the bottom up to the top right, from left to right. That is a positive slope. That's why those two are connected with each other. The other eye is that horizontal line to represent the negative symbol, and that eyebrow goes from left to right going down. So those two go together. If you look at the nose, there's that vertical line there, and then the bottom of the nose is a U for undefined. And then the mouth is a flat line with 2 zeros on the end. So that slope is 0. So again, take a picture of slide 5 so you have it, or just write yourself a note somewhere to go back and look at slide 5. Now, if you look at slide 6, there isn't anything for you to do on slide 6 either. Slide 6 is the basic directions for finding slope on a graph. And here's what I know. I know you know how to draw triangles, and I know you know how to count. And so finding slope actually should be pretty straightforward and in the category of relatively easy for all of us, as long as we pay attention to where we put the numbers. So if you look at that picture or that slide, the directions say to find the slope of the line, find 2 lattice points. Those are points where the grid lines cross. So as you're looking at that graph, see those blue dots? Those blue dots are sitting right on the corners of where those lines meet. That's what we call lattice points, easy points to use. That's the first thing. The second is you are going to make a triangle using those points. Notice I've made a triangle. I've got 2 different colors, and that's specific because I want to draw attention to something called both the rise and the run. Okay? The rise is how much something changes going up and down. If somebody rises out of their chair, they stand up out of their chair. Their body moves up. If somebody has a good vertical, they go up well. They jump well. Rise is the vertical change. Run, if I said, hey, run to the corner, you would run along the sidewalk or the street to get to the corner. So run is the side-to-side number. One thing to remember is that if your rise goes up, it's going to be a positive number. If your rise goes down, it's going to be a negative number. If your run goes to the right, it will be positive. If your run goes to the left, it will be negative. Now, if you haven't yet, come back to the meet and watch what I do on slide 7. I'm going to demonstrate it for you, and then I will have you practice. So as you look at slide 7, thank you. I see most of you have switched over to the meet. As you look at slide 7, I've given you a line. The first step is to identify those lattice points. Those lines or those points are already identified for me, these blue ones. The next thing that I'm going to do is indicate the rise and the run with my triangle. So I am going to work left to right, and I'm going to grab and draw a line going up. And remember, we said that if we go up, it's going to be a positive number. And then we just have to count how many lines up that went. So 1, 2, 3. Because we went up 3, that is going to be a positive 3. Then we switch from that corner and we go over to the right. And if we go to the right, it is also positive 1, 2, positive 2. Okay. Now from here, as it shows in slide 6, you're going to write this as a fraction of the vertical change, the rise, over the horizontal change, which is the run. To enter fractions, if you weren't sure of, you can click this little square root symbol and it'll open up the equation editor. And if I want to do 3 divided by 2, if I use that division symbol on the keyboard, the one below the question mark, it'll make it into, try again, 1, 2, 3. It'll make it into a fraction for me. And then I'm going to click submit. Now, one thing I do want to point out to you before you switch over and try on your own, I could work right to left, but here's what I know is that we sometimes make mistakes with our negative numbers. Okay, I went down. If I go down, my slope is going to be negative. And this would be a -3. And then if I went to the left, my slope would also be negative, and this is a -2. And a -3 divided by -2 actually just turns into a positive. Okay, but I want you to try and get in the habit of working left to right as you are finding slope, because I think that is going to be beneficial in terms of keeping things straight. Okay, switch to your slide 7, please. Let me open it up for you. Sorry. Go ahead and switch to your slide 7, and I want you to copy what you see on my screen for finding your slope. And then when you're done with 7, I want you to try 8. Keep in mind that the slope in slide 8 should end up negative because your line goes down to the right. Go. Slide 7 and slide 8. Oops. I should not have switched it yet. Sorry. Sorry. Oh, my lines are gone. Darn it. Let me put them back in there real quick. It was up 3. And it was over 2. Over 2. Sorry about that, folks. All right, and then while I'm here, I'm just going to add this onto this slide. If you go up, it's going to be positive. If you go down, it's going to be negative. All over. If you go to the right, it will be positive. And if you go to the left, it will be negative. All right, again, when you are finished copying slide 7 on yours, move up to slide 8 and give that one a shot. Jefferson, you should be copying my slide 7 onto your slide 7, buddy, and then doing slide 8. I'm going to give you a little bit more time, and I will move on and check your answers to slide 8 in just a moment. And then we will talk about the next part, which is something called y-intercept, which we actually also talked about last week. If you remember, that's the starting value. Again, when you're done copying what you see on my slide 7 onto yours, move up to slide 8, please. Brenda, I'm looking in Go Guardian. Nice job on your slide 8 in terms of your triangle. I didn't look to see what you have for your fraction yet, though. Brian, on slide 8, draw that triangle, buddy. Adrian, your triangle's perfect on slide 8. Now you just have to count your rise and your run. Martez, that triangle will work also. Just make sure you're paying attention to your positive and your negative number as you type in that fraction. Okay, remember when you do slope, though, you want to write it as a fraction, Martez, not the action of what you're doing, but a fraction, like we did on slide 7. Maddie, you have the right idea for some of it. Can you count again and then also pay attention to whether you're moving up and down or side to side with that slope, okay? All right, folks, I'm going to take a look at slide 8 myself. If you want to look at the meat, I'm going to walk through what you need to do. Remember, the first step is always to identify your lattice points, which are already there for us. And then I'm going to work left to right. So I am actually going to start at this lattice point, and then I am going to go down. And I'm just going to put the little arrow at the end of my line to remind myself that I'm going down. And when I go down, it means that number has to be negative. And when I count, it's 1, 2, 3, 4, 5, 6. So when I go down 6, my rise is -6. And then from that corner, I'm going to go to the other lattice point to the right. And I'm going to put a little arrow at the end of it to help me keep track of that as well. And since I go to the right, 1, 2, my run is +2. From here, I can enter that fraction multiple ways. We usually try to simplify it as much as possible. For today, though, if you had -6/2, that's fine. Or you might have -3/1. Because you might have been thinking, oh, I could probably simplify that fraction, or you might even just have -3. So take a look at what you put for slide 8. If you need to fix your slide 8, please go ahead and do so. Again, the nice thing is once your Desmos, once your answers are on your slide, you always have that to come back to. Okay, once you have fixed your slide 8 to be similar to mine. I'll open up slide 9 in just a second. I know there was a couple of you who had done your major triangle up here above it. Let me just pick 2 different colors and I will show you what you're going to do for that one. You did a good job. I saw you guys made your triangle. So here is over 2. The big thing to remember is that this 2 is going to go in the denominator of your fraction. If you can see yellow. You can. And then I'm going to draw that line down. Again, excuse me, again, when I go down, when I'm drawing my triangle, I have to remember that that is going to be a negative number. So either way, notice I've got -6 on that vertical part, and I've got a +2 on that horizontal part. So the big thing here is just to make sure that you are keeping track of your rise and your run. Maddie, good question. Excuse me. I bet it's erased. Okay, so Maddie, I will actually type it in the box because I think it's gonna take me less time to do it here. For your rise, if you go up, it will be positive, and I should say, or if you go down, it will be negative. For your run, that's the number in the bottom. If you go right, it will be positive. Or if you go left, it will be negative. It might be a good idea, because you're not going to see this on your slide, it might be a good idea for you to take a screenshot either on your Chromebook or if you have your own device to do that. All right, I'm going to unpause. When you have what you need there for slide 8, go ahead and bop up to slide 9. Davon, we're on slide 8, finishing slide 8 and moving up to slide 9, please. All right, again, get what you need on slide 8 and then head up to slide 9. We're going to switch gears and talk about y-intercept. We talked about y-intercept last week when we talked about the starting value. The problem that comes to mind, the two, are the cell phone problem where you bought the new phone, you paid $750 for the new phone, and then you paid $30 each month. So the starting value would have been that $750. That is the y-intercept. If you think about the race with the mom and the daughter, the head start that the daughter got, that is the starting value. That is what we refer to as the y-intercept. So as I take a look at slide 9 with you, here's what it says. It's where a line crosses the y-axis. So you see where that red dot is. That's what we call the y-intercept. Okay, in this case, when we talk about the y-intercept, the first coordinate is always 0. And then in this case, this coordinate pair is at 0, 2. Again, you go nowhere side to side, but you go up 2. It doesn't matter. If my point was down here, then my y-intercept for this one would be 0, negative 3. Okay, so the y-intercept is just the point on that y-axis. That's all it is. So go ahead and look at slide 10. Slide 10 gives you the graph where it's showing you this point. Oh, I don't need to be in the middle of the graph. All right, it's showing you this point right here. That red dot is what is located at 3, 0. Notice it is sitting on that x-axis. So I want you to enter coordinates in line 2 to plot a point on the y-axis. Folks, to do that, just click in that little 2 area box. It'll switch it to blue. And then as you are typing in the coordinate pair, make sure that you use parentheses. Use parentheses, and then you're going to start that coordinate pair with a 0 because that's going to be what gets you on that y-intercept. So pick any number to go in that second number and see what happens. Now, first hour taught me how to switch the color of that second point. Once you get your coordinate pair typed in there, then click the little gear box and it'll let you switch the color. But I want to see what you guys are putting in there. Oh, look at that. 1, 2, 3, 4, 5 people have exactly the same thing. I love it. Oh, and you figured out how to switch the color. Nicely done. Again, to get that y-intercept, you need that coordinate pair to start with 0. Let me go back here. You're going to start that coordinate pair with 0, and then you pick any second number that you want. Okay, I'm going to pick negative, well, I'm going to do negative 2.5, see what comes up. I'm going to switch my color. I'm going to pick, oh, why didn't it give me the color? What did I do wrong again? I want red. There. I want green. All right, so if you look at my screen, you'll see my negative 2.5 is down here on the y-axis. Again, the y-intercept always has to start with the number 0. Always has to start with the number 0. Trust me, there are going to be some people who mix that up, but make sure that you're getting that dot so it lands on that y-axis. I see everybody who has a second dot on there has a nice, has it perfectly done. Okay. All right, next slide. I want you to take a look at slide 11. There's a graph on slide 11, and it's a purple line. And the directions for slide 11 say for you to move that y-intercept and observe what happens. So click your cursor on that y-intercept. You'll see a purple dot show up. And then I want you to click on it and then just move it up and down that y-axis. And I want you to pay attention to what happens along that line and or what happens with the purple line. And then whatever observations you have, they're going to go on slide 12. Go. Hey, Davon, we're up on slide 11, buddy, 11 and 12. Isa, slides 11 and 12, please. Jefferson, slides 11 and 12, please. Again, slide 11, grab that purple y-intercept. You're going to move it along that y-axis. Observe what's happening to the line in the y-axis, and then on slide 12, enter your observation. Again, on slide 11, grab that purple dot and just move it up and down that y-axis to see what it is happening. And then you're going to enter your observation on slide 12. I would like to see what your observations are. Oops. Good. For the most part, everything I'm seeing is pretty spot on. One thing that I want you to notice is that somebody had said the steepness doesn't change, or changes. It actually doesn't. I wish I had the opportunity to move it and then freeze that one and then grab the dot again and add in another line, just so you can see that it doesn't actually move. Oh, I have an idea. Let me go here and let me do this. You guys see it? Switch over to the meat, you guys. For those of you who thought that the steepness changes, look at all the purple lines that you see on the screen. Those are all the purple lines where when you moved that y-intercept and you just left your line there, which is fine. If you see all these purple lines, notice that they are all still the same steepness and they're all parallel. So the steepness actually doesn't change. It stays the same. So the only thing that changed is that location on the y-axis. Okay. Somebody mentioned the line gets smaller, and you know what? It gets smaller only because it runs out of room up here. But technically, that line goes on forever. But in terms of the steepness, that's what you have. All right. I forgot about that overlay option. I like that overlay option. All right, look at slide 13. Slide 13, based on what we just talked about, starting at slide 9, what is the y-intercept of that graph? Good, Jefferson. I saw your answer. All right. Let's see what most of you have put for an answer. Good. Yeah, this one was very straightforward. This one is just asking you, what's that y-intercept? And most of you, I noticed, put this as a coordinate pair. I love that. I feel like that's going to be more beneficial to you when it comes time to writing equations, actually. So remember that y-intercept, you didn't have to do this, but that y-intercept is right here where that line crosses the y-axis. And so in here, you have to ask yourself, what's that coordinate pair? Okay. And in this case, that coordinate pair, you can write it as 0, 2, or I will tell you I would accept just 2, but I think it's going to be more beneficial if you do the coordinate pair. All right, so the rest of your assignment is actually to finish all of the slides up through slide 22 in terms of slope and y-intercept from a graph. And if you have any questions, feel free to drop them either in GoGuardian or in this chat here. And then also remember to go back and finish any of the Desmos 1, 2, and 3. So we've got a few minutes left in class. So you can go ahead and get to work on that.